Welcome to the massive open online course in computer science. The subject operating systems, the topic levels of security in operating systems. It is true that to maximize the utilization of the available resources, multiple users will have to execute multiple tasks on the same set of resources, and therefore, there is a need for an operating system to ensure that the resources are utilized optimally and the users are protected from one another, and there is no security threat from outside, because every machine is now connected to the network. The network is the computer. The resources can be anywhere, the people can be anywhere, 24/7 operations. In all these cases, we need to have very clearly defined and implemented protection and security mechanisms built into the operating systems. Protection and security for several years in the development of operating systems were automatically deemed similar to saying internal and external, internal threats and vulnerabilities, external threats and vulnerabilities. Today, that distinction is blurred. We need to have good mechanisms in place for protection and security. Therefore, the earlier descriptions that protection is the first level, security is the second level, is not the same today. The levels of security which we are talking about today are completely different and distinctive. We still say that 90% of the users of our systems are all into these ideas and working together through some kind of an awareness, through some kind of an assurance building, to some kind of a negotiation. We can always bring 90% of the users working along the lines of the operating system, where there is a need for increase in the protection, increase in the security on a per case basis. If it is well justified, they can talk to the administration and get the thing facilitated. However, the golden rule is principle of least privilege. Even though the concerned user may be very senior, very high in the hierarchy, it is the task that the user wants to perform that eventually determines the privilege. There is definitely a distinction between the way the software systems and operating systems work and other social systems work. We need to understand that there is a need for explanation, there is a need for clarification, there is a need for negotiation, there is a need for persuasion to bring 90% of the people getting into the way we are managing protection and security in operating systems. Simple rules like take a backup every Thursday afternoon will be violated at least by 20% of the users. We simply forgot. On that day, I didn't bring the backup drive. Every weekend there can be a scheduled shutdown of the system. We forget, we keep thinking that is there on that day, we do not plan. We are not very clear minded on how to plan our work, how to execute. We expect that all resources in the operating system are there 24/7 from anywhere in the world. We should be able to go work whenever the idea comes, we should be able to work. That is how we have built the computing systems. Security violations do occur. There are intentional, malicious security violations, unauthorized reading of data, unauthorized modification of data, unauthorized destruction of data. These are the most common intentional malicious violations which are tried out. So, what good systems design does is take away everything concerned with data into a database management system, simply pass all data related things to that management system, which is localizing any serious concern. It does not affect the operating system, which is taking care of so many other users. Data is done with a purpose, data is gathered with an intention, but with a specific functionality. Multiple databases can exist, those are the database users. intentional malicious security violation, people try to get at the data, and therefore, we have kept it separate. Let it be dealt with separately. The remaining functionalities of the system are taken care by the operating system. The database management system talks very cleverly to the operating system, so that wherever there is a data breach, it will be something outside from within the data and data related activities that goes for the rescue. The breach can be limited, the breach can be localized, we can easily manage many breaches. Please do understand that we do not have the wherewithal, we do not have the technology, we do not have the financial resources to think of a huge stack of security layer protocols which will cost us a lot. We cannot spend so much time on security. In many cases, security is merely a perception. If there is a financial resource, we would rather increase the memory, we will increase the bus capacity, the way we spend our monies will be different in the same resources. Security happens more as an afterthought in the way we work, we budget, we build our systems. However, it is very important because today network is the computer, and it is the reasonable degree of assurance, persuasion, knowing the limitations of what the protection and security mechanisms are offering in a given system is a great help. We have to work around that. There are of course accidental violations. How will the security attacks happen? System calls. System calls remain the best way in which an application program can interact with the available code in the operating system. Operating system is also a piece of software. It is written by brilliant systems programmers. It gives you a direct way of working with the hardware very effectively and very efficiently. Application programs can be developed faster, application programs will work faster if the application programmer cleverly brings in the system calls into his program, and we have a way of managing how the system calls in an application program use the code of the operating system, make themselves more efficient and more effective in quick time across multiple users. So, what we have done here is that we have given a wonderful facility for the system calls, and system calls remain the number one method by which a security attack can happen. An illegal set of parameters can cause a breach. So, what we did was the entire system call implementation will happen with the active support of the kernel, and if a system call fails, it is simply aborted. We do not do anything, it will simply be passed on to the application program saying that there is an abnormal end, memory fault or something, and the entire core of the program will halt, come to a grinding halt, and it goes into the user saying that something happened at this time, you please take a look at it. A typical system therefore works by limiting its involvement. The system does not get so much involved with anything, it is only talking about where to position what. If there is an error that is occurring in the system call, it goes to the application program. If the error is occurring in the data related matters, it goes to the DBMS. So, simple kind of a demarcation of how the breach can be handled is a great help which an operating system designer can provide. Break-in login process, most of us are very bad in keeping track of our passwords, telling the password in a manner where its confidentiality is still there or not there. We are not conscious about such things. Break-in of login process happens very frequently and very commonly. That is the next problem which we are facing, breaking of login process. This is very frequent. System calls are at least done carefully. People have been trained to use system calls. Good application programmers are there. However, as we move into building application programs across the network, we are not able to make secure programming. We seek language support. The earlier topic on security talks about language support. Java, for example, has fantastic built-in features for security. We are talking about extensions of the existing languages like C to make secure C. Memory information, many systems do not erase the space before allocation. We are very notorious in taking care of memory which we sought, what we did with the memory, and while exiting we forget to clean up the memory. This is a big error because it will remain as a garbage. We need to make sure that the operating system helps to some extent by running routines called garbage collection and on the fly garbage collection, putting together the memory pieces, compaction and garbage collection. Garbage collection and compaction are services provided by the operating system to make sure that these kind of errors are minimized. It is not coming to a 0, but the application programmers are like that. They forget to clean up the memory. There is some junk already existing in the memory location which was sought dynamically, and that junk eats into the program. It may result in havoc. Bad login programs. Write a login program that records other users' authentication. We did this as a simple game. You can write an application program that mimics the login screen. Those days the login screens were all very simple, text based. There is no graphic, nothing. You would simply leave the program showing a display screen, login prompt, password. 60% of the users will think that it is the original login screen. They will give their login name, they will give their password. Password recording, now there are clever screens. The screens have become intelligent. Whatever you are typing is not appearing to you, but the screen memory is noting what you are typing, and from the screen memory it can be taken. If somebody is hell bent on breaking into the system, he or she will. There is no second opinion about it. We do not have the resources, we do not have the wherewithal to think of foolproof mechanisms. 100% secure is a very distant dream, and maybe it is not pragmatic or even wise to think of 100% security when 90% of your users are falling in place. They are all there, you have to simply persuade, you have to negotiate with them and make it happen. The security threats manifest more in terms of bacteria. Program that consumes system resources by replicating itself, it simply plants, all memory is over in 2 minutes. Why? It is simply filled with junk, it replicates junk. Logic bombs, trapdoors, these are Trojan horses, virus, worms. So the point I wish to make here is that all these are usually called various levels at which the operating system is built. The way the functionality of the operating system, implementation of system calls, implementation of login processes, the memory information, the way they are cleaned, garbage collection, compaction, all these things are necessary to build that assurance amongst the various users that they are, the protection and security mechanisms are all nicely taken care of, to an extent where we are able to marginalize the external security threat, the accidental security threat, to a minimum 10% of the exercise, and that is done separately. We keep talking about the 90% of the people who get benefited by the performance of the operating system on the response time, waiting time, throughput and the others. The traditional security architecture is here. It is very clearly telling that there will be some kind of an authentication the moment the network interface is there. Likewise, the database server is thrown out with a separate network interface and separate network. So this is separate, database server is separate. So authentication at the time when it is interacting with the network, and the database server has a separate network interface. So we have this application and application server. We have a server, we have the application. These are the two dominant things that are in the minds of the users. At the time of network interface, we talk about authentication, and the database server is simply put aside with the network interface. Something happens in the network which relates to this entire exercise of authentication and network interface. That is how we have been architecting our OS level solutions, because wherever there is data, we simply think that there will be breaches, malicious, intentional, and that is exactly how we are diverting people also, to tell that this is the place where the data is there. If you know data, if you have the data, data is power, information is power. What we keep telling is use of information is power. On its own, information is not power. We download everything, tons and tons of information is being downloaded. If you don't use it, it is not power. Information on its own is not power. The use of information, effective use of information, tells you the grade of the power that you can generate. So this is how we have been talking about the way in which we have been building the systems. And what happened in the traditional security architecture is that the authentication became a big bugbear. Passwords were given freely, If you ask the password, they will tell. We are very, very careless. We don't even remember the password. In a given week, every user would have gone into this spell. Oh my god, what is the password that I have used for this particular package, for this application? We rackle our brains. Invariably we will tell, I forgot the password, please resend some password, I will change it. Credit cards, number one security threat now. Credit cards, credit card numbers online, we do not know how the breaches are occurring. Outside of the data, financial institutions are the most vulnerable. It's not merely data, the financial institutions become more vulnerable. They have more robust mechanisms. They will go for credit cards, biometrics, they go for many other ways of talking about authentication and isolation. We should know when a breach has occurred, how to quarantine that, how to quarantine a breach. At the earliest, we should be able to come to the IP address, we should be able to come to the user and say why that breach has occurred. How do we trace it? For so many years, we have been thinking that on the internet we will be anonymous. Now it is no more true. We are not anonymous on the internet. We can be tracked. We have built systems, we have built surveillance, we have built so many things that it is like that. And anything that goes into this kind of a system is not exactly the way the social system works, but it needs to blend. That is how we talk about it. Remote location verification, somebody has logged in our system. Most of the times we block remote logins because it's a clear conduit for facilitating any breach. Anybody can log in, or if you want remote login, you have to provide a justification and then create a remote login for yourself. That's how it is. Design of secure operating system, we need to identify the users, the physical access, who can access the machine. There must be an identity card. One identity card will save so much of explanation, so much of analysis time. Just flash the identity card and then you can go ahead. Authentication of users, passwords, hardware keys, biometrics, protection of memory. Memory cannot be allocated to whichever application program is asking. There are access permissions, there are restrictions, file and IO device access control, allocation of the access control to general objects, enforcement of sharing. There must be sharing rules. Sharing violation should be spotted by the system. All these are simply indicating that the functionalities of the operating system have become more and more intricate in design, more and more intricate in policy formation. The mechanisms will happen later, but then the policy formation in operating system is becoming more and more intricate. We need to guarantee a fair service. We simply cannot block resources. Interprocess communication and synchronization, logging of user actions. No system is perfect. We have made several compromises, we have made several adjustments, we have made several ways of building a system in the scenario of many conflicting interests. So a particular implementation of an operating system would have done all this in this manner. Other system may be doing it differently. We need to make sure that portability, interoperability remain the watchwords to keep up to that goal which we promise to the users, that 24/7 resources will be available. The users can be from anywhere. It's a very good goal which we have positioned, and that way the user base will become strong enough and we make productive use of the systems that we are building. We should have a reporting mechanism by which any breach of security is automatically reported and any violation can be said. This happens by the education of the users. They should be educated to spot them. Physical separation, different hardware. People who have pairing violations in a strong manner should use different hardware. Temporal separation, some people will work in the morning, some people will work in the evening. Cryptographic separation, logical separation. Today we have the same infrastructure being used by different people in a different manner. Some people are capable of taking you to the 3rd floor, some people are capable of taking to the 8th floor. Nobody other than the top man is capable of taking you to the 15th floor. We cannot access all floors. Floor restrictions, infrastructure access restrictions, everything is operating in a manner where at physical level, at temporal level, at crypt level, at logical level, we have built a nice distributed secure system which is available 24/7 to all people wherever they are. These are the ideas that were published in 1983, and till today we think that these are the 4 ways. Levels of security offered by the operating system: no protection. Isolation: each process has its own address space. This is normal, the shell. When a user logs in, he gets into the shell. We did that shell scripting that gives the feeling of isolation to every user who has logged in. Whatever that shell environment permits, only that happens, nothing else happens. The user is automatically isolated from other users because of this shell. Share all or share nothing: it is a case of sharing rules, sharing violations, policies for sharing. We can talk many policies. Share via access limitation, share by capabilities, limit use of an object. This object can be used by only 1, 2, 3, 4 people, not others. All people are not the same. There are categories of users. Users are created based on certain privileges. Users are created, classified based on the groups in which they must work because of the demands of the project or the work they are doing. Others are different users. So, for a given exercise, for a given purpose, or for a given task, we dynamically look at who can use, what is it that is going to be used, what for, at what time, at which physical location. These are the simple ways in which the functionality of the operating system is now becoming very sophisticated, and the conflicting demands of other 18 or 19 functionalities makes us do some compromises, well engineered compromises, and we say that this implementation does like this. This is how it operates. What do you know? Password. What do you possess? A token or a special key. Unless I put a special key into this machine, it doesn't work, it doesn't get booted. Something about you, a picture, a fingerprint, or iris scan, or a texture, or whatever it is. So, these are the typical ways in which authentication happens. All authentication mechanisms must be easy to use, inexpensive to install, difficult to subvert, hard to bypass. Well, most of the times it is like that. Whatever we do, the users are users. 90% of the users are innocuous. We tell that before entering this facility, you please write in the register at the entrance. 15% of the people forget to do that. On a given day, minimum 15%, they will have to be called back. In addition to a register, you should also have a person who notes that somebody went in without writing in the register. 70% of the people are very good in writing the in time, but they completely forget the out time. But still, it is our task, our duty to ensure that who is using what. Automating this system helps to an extent where we can simply swipe an RFID card and you are registered. When you are coming out, you swipe, out time is also mentioned. However, these RFID cards create more expense. Intelligent ID card, I have an intelligent ID card. When it is shown into an appropriate machine, it will get lot more details about me. At the entrance, you are going into a very sophisticated facility, and this ID card has a chip which documents a lot about me, and if that person's machine is capable of reading that chip, it tells a lot about me. I didn't create, I don't even know what it is there. As we progress, they may add data into that. So, these are certain things which we are making to make sure that all these smart RFID, etc., it's a smart IDs, everything are becoming difficult to subvert. There is no denial that so and so person has gone in, so and so person's trace is still there. It's hard to bypass. Password management, difficult. Assign initial passwords, change certain user passwords. All these things have made the systems and the systems designer think that people are people at the end of the day. They cannot be asked to memorize 10 passwords which they need. Unification of password may create a bigger havoc. What is the advantage of unifying the password? It may be easy for the user, but one leak of the password will leak everything else. The user must be made aware, the user must be persuaded into believing that you please think unification of password is good, but then these may be the problems. Token, something as a key, car keys. How many times we forgot the car key? Today we have a technology that locates the car key. There is a small intelligence built on the car key. From a mobile, you can simply buzz the key, it will tell where it is. We leave the car, kept it somewhere, we do not know where we have kept the key. Happens in a given day, 10% of the key owners of cars have this problem. Limitations can be very expensive, user must carry with him, can be given to unauthorized user and we forget. Biometrics, signature, letter spacings, fingerprint, palm print, iris, there are so many ways. It is about the person, the user, and this we think is very strong because no user would want to lose himself or herself, but then if somebody is hell bent into breaking into the system, he or she will. Retina scan, voice, more and more technology, Fourier transform, so many things are being used. Essentially, what is it that we are talking about? We build trust in the OS. This is how the OS functions. These are the ways in which we give protection and security, and you can trust the OS based on what are the mandatory access controls, how it prevents or facilitates object reuse, how the complete mediation process and audit. These are the 4 aspects which are to be made known to the users for them to build trust in the way we have implemented. Once again, we keep telling we are not creating a 100% secure system, we are not building 100% foolproof systems. So, the aim of this topic is to see how by doing so many things at the operating system level, we increase the trust in the operating system across the minds of 90% of the users 24/7 anywhere on earth. Mandatory access control, this is something which is very essential for us. This is what tells discretionary, DAC is discretionary access control, where the systems administrator will normally, we do not allow people to do this, but you have a justification, therefore we give you this access control, and we think that it does not violate the mandatory access control, but whatever is the mandatory access control that has been listed tells about the system. For example, people who bring their own pieces of equipment will have to go through a separate process. The equipment within my organization is managed. Somebody from outside, we can create a draconian rule saying that whoever comes into my campus will not be allowed to use any of their machinery. Or other way of doing it is, tell us what is the machine, you please tell us whether you want an internet connectivity, send us the IP address, quick time, within no time your machine will be connected and you will have an IP address, you can connect to the internet. The choice is ours, we make a choice. The mandatory access control mechanisms indicate the level of trust we can confide in the operating system, because we know the OS is built like this. Object reuse, access control list, printers are accessible only to these people, the floors are accessible, object is a more generic idea. In case there is a breach, we have an audit, we have a complete mediation that is possible here. So, what we need to think is a way in which we can combine our understanding of the operating system based on not the 20 functionalities, not the intricate virtual memory, not the intricate scheduler, not the intricate IO management, that is a different idea. File management, that is technology from within the operating system. From the perspective of the user, it is necessary to understand what are the mandatory access controls implemented, how is the protection mechanism for using the objects implemented, what happens if there is a breach, what kind of mediation mechanisms are there, and how will I be assured through an audit check. These are the ways in which we build trust in the operating system. Intrusion detection, there are certain anomalous activities. At a time when most of the campus is sleeping, if my server is hyperactive, I get a doubt. Nobody is there, nobody is awake, and if the server is showing lot of activity, then there is a problem. Attack detection, these are the ways in which we are talking about. Today we have full-fledged, very sophisticated intrusion detection systems which can be built in homes, which can be made for homes, which can be made for any infrastructure facility, but how do you know who is an intruder? Given any system, we can find a way of breaking it. So, what is the improvement that we have brought about? We brought about the same thing, but then we made the authentication robust, we made the database server very robust. All these things now are in a separate casing, trusted. There is a trusted base on every of these. Earlier on we were not. If you look at the earlier picture, we were not talking about anything called trusted. The earlier picture simply tells that it is a strategy. Now, across all those servers, we have created a way in which this is what is the standard OS, where we have simply spoken about the raw servers, and then what we have done is we have gone ahead and built a trusted base. Now, into this the audit, the logs, everything has come. We create a trusted path saying that these applications, these users have taken only this trusted path. If they have taken the trusted path, they can be trusted. There is no problem with that. Allowed paths, allowed interactions, allowed way of working with other systems and other resources, there is no problem. So, this is our strategy, a kernelized design, a trusted computer base, which builds all these levels, and we created a rainbow series: orange book, tan book, amber book, dark lavender book, which talks about the various levels. Every book has its own problems, every book has its own capability. It can take you up to a level. Beyond that, you are the concerned person, you are responsible for your work. The operating system will take you up to this far. Implementing the various book, dark lavender book, is going to be very expensive. One system that has built Aqua book, purple book, light pink book, many more. There are so many such things. Please understand that the rainbow series will give you multiple levels of security in the operating system. One good mechanism of having a formal verification testing is possible. This is all is the content of every book. The content of the book is clear: awareness training, background checks, separation of duties, split knowledge, policies, data classification, effective user registration, termination procedures, change control procedures. But the degree to which validation can happen, verification can happen, and testing can happen differs from each book. As you progress, orange book is the default, very easily maintainable one, but it is very simple. Dark lavender book, very expensive. Light pink, more and more expensive. Covert channel analysis. As we progress in this rainbow series, we have more and more cost associated with that. There are all levels which are described in this book: discretionary and mandatory access control. These are the ways in which we create multiple levels of implementing security mechanisms alongside protection, which are now dealt with together in a given operating system. Policies may be many. A particular operating system will implement a policy like this, tailored to that particular context, the way we are working. These are the ways in which you can feel trusted in the OS, and the OS can be trusted. The trust level of the users, the trust level of the OS are nicely manifested in this as per the books. The rainbow series of books is very important. Thank you.